welcome. In Australia, there's not a satellite that has been launched into outer space until now. Today, my research paper is about CubeSat, called SkyHopper, which is launching by the end of 2021. The University of Melbourne, with the help of their scientists, is undergoing with this mission. The main areas which I'm addressing throughout the video is: what is a CubeSat? What is a SkyHopper? And what mission is the satellite going to carry out? Let's go to the first question. What is a CubeSat? A CubeSat is like any other satellite, but the only difference is that it is small. A 1U CubeSat is 10 by 10 by 10 centimeters cubic units with a mass more than 1.33 kilos per unit. These CubeSats are micro-sized. A university used them to conduct their own experiment. The CubeSat was first proposed at California Polytechnical in 1999 to allow university students to explore space, and since then about 875 CubeSat has been launched. So now that we know what a CubeSat is, now we're going to see what a SkyHopper is and how it will expand our knowledge on space. The SkyHopper is a space telescope. This is a 12U CubeSat with a dimension of 22 by 24 by 36 cubic centimeters, weighing 24 kilos, which will be operational in low Earth orbit. The SkyHopper idea started in June 2015 at the University of Melbourne by 4 scientists. The reason why SkyHopper is different to the other CubeSat is because of its infrared telescope, which observes light of a distant object in the universe. And by the name itself, it can hop around Earth orbit, being one of the quickest satellites. The reason why having an infrared telescope on a CubeSat, because from Earth's atmosphere, it is hard to see distant objects because of water vapor in the atmosphere which absorbs the light, which makes it hard to see the distant objects. So with the infrared space telescope, which is implanted on the SkyHopper, it will be able to do the following mission. Search for other Earths, because that is able to detect distant objects, identify gamma ray bursts, and last, to measure the cosmic infrared background. One of the missions that this SkyHopper is doing is to search for other planets that have the same characteristics as Earth. The reason that this CubeSat will be the best to look for habitable planets than the upcoming NASA Transiting Exoplanet Survey Satellite, or TESS, is because of its infrared telescope that is able to detect distant objects. The reason this mission is important to find other habitable planets because as human civilization keep on evolving in technology and population, our planet will soon finish all the resources, and the pollution level will rise because of the carbon footprint that we leave all over the world. Therefore, as our population increases and new problems start to arise, we need to find a new planet which we can start first and learn from our mistakes. Another mission that the SkyHopper is doing is to identify gamma ray bursts. A gamma ray burst is when two neutron stars collide onto each other. Then they emit a black glow, which is 1,000,000 times brighter than the sun itself, and emits a gamma ray. After they finish, it creates a black hole. From Earth, all you can see is a small dot of light which lasts only 2 milliseconds because of how far away it is. We have only discovered about this electromagnetic outburst in early 1970. Since then, they have noticed hundreds of bursts, but it still remains a mystery. But with the SkyHopper infrared telescope and how it can hop around Earth quickly, you'll be able to see this gamma ray burst and be able to study and see how it's formed, which could explain about the expansion of the universe and the Big Bang Theory. The last mission that the SkyHopper is doing is to measure the cosmic infrared background. What is the difference between the cosmic infrared background and the cosmic microwave background? A cosmic microwave background displays the aftermath of the Big Bang, while the cosmic infrared background contains the whole history of every evolution, formation of stars, supernova, stellar evolution, dust production, and black holes since the Big Bang. Because this telescope is out of Earth's atmosphere and it has an infrared telescope, it will be able to map out all the cosmic events that has happened. Thank you for watching. I hope you learned more about SkyHopper and be ready to see it launch in 2021.